Hi folks, we're going to take a look at number 10 from page 443. So they're asking us to determine the angle between these lines in 2D. Now they actually specify the acute angle, but just keep in mind that our convention is that we always assume that we're looking for the acute angle. So if you come up to an obtuse angle, you have to find its complementary angle by subtracting from 180. So there's two ways to find the angles between the angle between two lines is to either find the angle between the direction vectors, or you could also find the angle between the normal vectors. So if I look at B here, both of the equations are given in parametric form. So what's easy to find here are the direction vectors. So that's what I'm going to use. So here, the direction vector for this first equation, you just look for the coefficients of t. So it's going to be negative 5, 4. Okay, and the direction vector for the second line is going to be 1, negative 6. Okay, so you see here we're not interested in the points, we're just interested in those direction vectors because they represent the direction of the line. Okay, so the best way to find the angle between two vectors is to use the dot product. So I'm going to take negative 5, 4, dot it with 1, negative 6, and we know that that's going to be equal to the magnitude of the first times the magnitude of the second times the cosine of the angle between them. Okay, so here we've got negative 5 minus 24, so we've got negative 29. Okay, equals here we've got 5 squared, 4 squared, so 25 plus 16 is 41. Here 1 plus 36 is 37. Okay, times cos theta, and so theta is just equal to cos inverse of negative 29 over root 41 times root 37. Okay, and here already I can see that I'm going to get an obtuse angle because of the negative. So just have to make sure that I switch it to an acute angle. So here, let's calculate this. So inverse cosine. Okay, and we've got negative 29 divided by, open up some brackets for the denominator, square root 41 times square root of 37. And we have here, as we expected, an obtuse angle. So here this is 138.1. Okay, but what we want, so we'll call it phi, is 180 minus that. Okay, since we need the acute angle. So minus 180, and we get 41.9. Okay, so there we have it. Now, B, okay, is a little different because we see that one equation is given in vector form, which is equivalent to parametric form, whereas the other one is given in Cartesian form. And in Cartesian form, what we get is a normal vector. Okay, so we're going to have to do a little switcheroo here. So let's start with the first equation. We have a direction vector, so 2, 4. Okay, and in the second one, we actually have a normal vector, 2, negative 4. Okay, so we have two options here. I can either turn this into a normal vector, or I can turn this into a direction vector. Okay, so either one will give you the correct answer. So here I'll turn this into a normal vector. So since a normal vector is just going to be perpendicular to that one there, all we have to do is flip the x and y coordinates and change the sign on one of them. So 4, negative 2 would be a vector perpendicular to that one. Negative 4, 2 would also work. Okay, so I'll now work with these two angles. So I'll do the same as before, take the dot product. So 4, negative 2, dot it with 2, negative 4. Okay, here the I'm going to get the same magnitude. So 16 plus 4 is 20. Here again, 4 plus 16 is another 20 times cos theta. So theta is just going to be equal to cos inverse of, okay, what do we have here? We have 8 plus, and that's going to be another 8, so 16 over root 20 times root 20 is just 20. And so here I'm going to expect an acute angle, so I won't have to make any changes there. So cos inverse of 16 over 20, and there we have 36.9. Okay, so there you have it. So just to recap, in order to find the angle between lines, you either find the angles between the two direction vectors or the two normal vectors. and it'll depend on what information you're given. In this case here, when it's sort of a mixed combination, one vector, one Cartesian, you'll have to switch one of the vectors to make it work. Okay, and of course a reminder that to find the angle between vectors you use the dot product, and of course your final answer should always be an acute angle unless they're exactly perpendicular, in which case it'll be 90 degrees. Okay, that's it for these.